आज का जो इम्पोर्टेंट क्वेश्चन है, फूरियर सीरीज आपको इसका फाइंड करना है और फंक्शन एफ ऑफ एक्स है वो ई एक्स गिवन है, इंटरवल इज माइनस पाई टू प्लस पाई. देन we start the solution because x belongs to minus pi to plus pi, and there let the f of x is equal to a0 plus summation of n equal to 1 to infinite an cos of nx plus bn sin of nx. This is the series, and now by this series we find the Fourier expanding value for e raised to x, and a0 is given by 1 upon 2 pi minus pi to plus pi f of x dx, f of x dx, and therefore 1 upon 2 pi integral from minus pi to plus pi fx, and f of x is given, f of x is equal to e raised to x, that means e raised to x dx, and integral of e raised to x is e raised to x. Therefore 1 upon 2 pi, and integral is e raised to x, and lower limit is minus pi and upper limit is plus pi. 1 upon 2 pi, we put upper limit in this function, that is e raised to pi minus e raised to minus pi, and this value is equal to 1 upon pi multiplied by sine hyperbolic pi. So therefore a0 is equal to 1 upon pi sine hyperbolic of pi. Now we find the another coefficient value an and bn, and for an is equal to an is equal to 1 upon pi minus pi to plus pi f of x cos of nx dx, and therefore 1 upon pi and minus pi to plus pi fx is equal to e raised to x here, so ex cos of nx dx, and the integral of e raised to x cos of nx, that means integral of e raised to ax cos of dx is equal to e raised to ax divided by a square plus b square, a cos bx plus b sin bx. Now we write the integral value of e raised to x cos of nx, and here a is equal to 1 and b is equal to n. So coefficient of x is a, and here coefficient of x is 1 and coefficient of x is n here. So the integral of e raised to x cos of nx is e raised to x divided by a square plus b square, that means 1 square plus n square is 1 plus n square, and a cos bx, that means a value is 1 cos of nx, that means cos of bx, that means b value is n, then cos of nx, and plus n sin of nx, and limit from minus pi to plus pi. Now we put upper limit pi as x variable and lower limit minus pi. Then an is equal to 1 upon pi multiply 1 plus n square is constant value, and therefore we put the upper limit pi in this function, then e raised to pi multiply cos of n pi plus n multiply by sine of n pi, and minus lower limit minus pi, then e raised to minus pi and cos of minus n pi plus n multiply sine of minus n pi. Because sine of n pi for all values of n, always n pi and minus n pi 0. So this second part value always 0. Then an is equal to 1 upon pi 1 plus n square e raised to pi cos of n pi, and here minus e raised to minus pi and cos of n pi, because cos of minus theta is equal to cos of plus theta, so cos of minus n pi is equal to cos of n pi, and sin n pi is 0 here and sin n pi also here 0. Now common is cos of n pi is a common value, then cos of n pi divided by pi multiply 1 plus n square, and here e raised to pi minus e raised to minus pi. We multiply numerator and denominator by 2, then this value change into sine hyperbolic function. Therefore, an is equal to 2 cos n pi, 2 cos of n pi sine hyperbolic pi divided by pi multiply by 1 plus n square. Now we find bn value. And bn is given by 1 upon pi integral from minus pi to plus pi f of x, that means f of x is ex, and sine nx, that means sine of nx dx, and integral of ex sine nx is 1 upon pi e raised to x divided by a square plus b square, that means 1 plus n square, and a sine of nx minus b value is n, b cos of nx here, and limit from minus pi to plus pi. We put upper limit minus lower limit in this integral. That means 1 upon pi, and 1 plus n square is constant term, so e raised to pi multiply a value is 1 here, so sine of n pi minus n multiply cos of n pi, and minus lower limit, that means e raised to minus pi, and a sine nx, that means a value is 1 and n is n, and x is equal to minus pi, that means sine of minus n pi minus n cos of n minus n pi. This is value of a. Now is equal to 1 upon pi multiply by 1 plus n square e raised to pi, sin n pi is 0, that means minus n cos minus n cos of n pi, and this value also 0, and minus and minus multiply, then plus e raised to minus pi multiply by n cos of n pi. Now n and and cos of n pi and n of cos n pi. Then we take common n cos n pi with negative sign. That is minus n cos of n pi is common. Then e raised to pi minus e raised to minus pi, the remains term, divided by pi multiply 1 plus n square. Again we multiply by 2 this value and multiply by 2 here. Then Bn is equal to minus 2n cos of n pi sine of hyperbolic pi divided by pi multiply 1 plus n square. This is Bn coefficient. And now the Fourier series is, and therefore e raised to x, the Fourier series is a0 value is 1 upon pi sine of hyperbolic pi plus summation of n equal to 1 to infinite an value, and an value is 2 cos of n pi sine of hyperbolic pi divided by pi multiply 1 plus n square and cos of nx, that means cos of nx, and bn, the bn value is negative, then minus bn value is twice the n cos of n pi sine hyperbolic pi and divided by pi multiply 1 plus n square sine of nx, that means sine of nx. And it returns as 1 upon pi sine of hyperbolic pi plus summation from n equal to 1 to infinite 2 cos n pi sine of hyperbolic pi divided by pi into 1 plus n square, and remains term 2 cos of n pi sine of hyperbolic pi divided by 1 plus n square, and remains term are cos of nx and minus 2n, so 2 cos n pi and sine hyperbolic pi 1 plus n square is common value, then minus n sine of nx. This is our Fourier series for the function e raised to x. Now next, the second part of the question, also find the sum of series. And sum of series is half of limit of h tends to 0 f of minus pi plus 0 minus pi plus h and plus f of plus pi plus h. This is the sum of series where limit h tends to 0. Then we put here h value is 0 is equal to half of f of pi, that means f of minus pi and plus f of pi, and by this sum of series is half of e raised to minus pi plus e raised to plus pi is equal to cos hyperbolic function, that is cos of hyperbolic pi. Hence the sum of series is cos hyperbolic pi, and the expansion form of the Fourier series of ex is given by this value, and where n is equal to 1 to 3 4 and values. तो इस तरह से देखिए इस क्वेश्चन के अंदर अपन ने ex फंक्शन के लिए फूरियर सीरीज प्राप्त की है, और इसके अंदर जो कैलकुलेशन है वो ध्यान से करना चाहिए, लिमिट रखते समय बहुत ही आपको ध्यान रखना है अदरवाइज आप थोड़ी सी भी चूक हुई तो आपका सॉल्यूशन है वो खराब हो सकता है। तो इस तरह के इंपॉर्टेंट क्वेश्चन जानने के लिए फूरियर सीरीज के अंदर बने रहिए। हमारे चैनल पे सब्सक्राइब नहीं किया तो सब्सक्राइब कीजिए और अपने फ्रेंड्स में अधिक से अधिक शेयर कीजिए। थैंक यू फॉर वॉचिंग दिस वीडियो।